It's that time of month again, time of week again, Sunday, 6 p.m. Welcome to Steve's Place. Um, Before we get to our guest, Bill Alec, I'd like to remind people at this time we do have a call for papers, and the conference is going to be August 7th and 11th for 2024. If you or know someone who have a presentation on research or maybe even a device that covers like Tesla technology, extreme physics, the list is there. Anyway, you should have them get hold of us. My phone number is 520-252-0374. That's my personal number. Or they can write to me at steve@teslatech.info and send me an abstract, about 250 words, a couple paragraphs, is all you need. Tell me what you want to speak on. Of course, we're looking for hardware, not hot air, so working devices always have priority. Okay, and anyway, I also want to remind people, to become a member of the Tesla Tech YouTube channel. Right now, we have the Extraordinary Technology Conferences up there. The Exotic Research Conferences are up there. And I'm working on the Global Sciences. I'm up to 1997. There's a lot of good information up there. Some of it you won't find elsewhere. I also want to bring it to your attention. You should become a member of the channel because any controversial material will always be set up there as members only. The reason being is YouTube is on a censorship kick, and they're censoring all types of material, and you can't keep track of it anymore. It's $9.99 a month to become a member for exclusive membership, gives you access to everything. The $3.99 one is just a donation. But anyway, so you go for the exclusive membership, $9.99 a month to get global access 24/7. I mean, you could be sitting in a trench in the middle of the Ukraine watching this stuff. I mean, it's just so incredible. We put most of our material out as a members only for one reason, because as a members only, you don't seem to censor it as hard as if it's for the subscriptions. And so if I see something there that's going to get me knocked off, because the censors won't pass it, I'll put it up there as members only, and have you be able to see it that way. Otherwise, they'll just take it down and nobody gets to see it. So anyway, just go to our website, teslatech.info, and you click on the yellow box, that's up there, and you can subscribe there. It's free to subscribe. If you want to join, it's $9.99. Same location. I also have a conference directory where I'm listing all the directories. When you click on that conference, it'll bring up all the videos in that conference. Same thing with the speakers. If you pick up a certain speaker, it should bring up all the videos for that speaker. They're still a work in progress. I gotta get caught up on it, but even so, I'll be adding on it all the time because I'm adding videos all the time. I got 1,000 videos up there already, and getting ready to put 1,000 more. So at this time, I want to bring Bill Alec up. And Bill has spoken at a number of our conferences, and in fact, he has quite a few videos up there. And he's been demonstrating over Unity for many years. How many years would you say, Bill?
Oh, geez. I really started the conference circuit, I would say right around 2001, I want to say.
I would say about that.
Yeah, right around 2001 is when I think I started presenting this material. Mm-hmm.
And you have a bachelor's, right? In electrical.
Right. Yeah, BSEE degree. And I'll get into a little bit of that in some more detail here in the lecture. Never once, I want to mention to the listening audience out there, is that never once was Nikola Tesla's name mentioned in any of my course studies. I went to Ivy League school in Chicago, Illinois, Illinois Institute of Technology. I graduated from that school in 1979, and never once was Nikola Tesla's name mentioned by any of the professors, which I thought was rather interesting, considering all the inventions that Nikola Tesla did over the years. It just never made it into any course studies. So there you go.
Well, I know that, like when I started, with the Tesla Society, um, our target was for professors and that, and a lot of them have come and thanked me for making it okay for them to talk about Tesla again. But before you get started, I just want to remind everyone to below the screen there, there should be to give us a thumbs up, so that the sensors will see that we're good and help us promote the Tesla stuff. And with that, I'm just going to turn it over to you, Bill.
Okay, Steve. Let me see if we got anything working here. Okay. Are you controlling it from your end, or maybe not?
You're in control.
Oh, I have control. Okay.
Because it's a share screen.
Oh, I see. Yeah, there we go. Okay, everyone. I'll be speaking today about replicating Tom Bearden's scalar wave technology. And if any of you ever met Tom Bearden, he's quite a character. And when he speaks, at a conference years ago, it's just quite fascinating. Okay. So let's get into this here. Okay, my timeline. Okay, back in 1977, while attending IIT, Chicago Engineering School, I was given a vision, and to me it was the most outstanding, incredible thing I ever saw. And I was constructing an anti-gravity disk. And at the time, I had no clue on how any of this operated. And it wasn't until many years later here, things started to fall into place. So in 1979, I graduated with a BSEE degree and began my professional career, as a hardware software engineer. And I worked at many corporations. Okay. And then in 1997, I found out about Tom Bearden through this researcher by the name of Richard Hoagland. Spoke about Tom Bearden. And Richard put together this conference in Seattle. And I said, well, okay, I'm going to go to this. And it was Tom Bearden giving a lecture on free energy and anti-gravity. I says, oh, okay. Things are starting to fall into place here. And so I attended the lecture and was just blown away by it. And, after listening to Tom Bearden speak, you think within a week or two, you can build one of these devices. It took me 20 years to put all the pieces together here. So in 2022 is when I began lecturing about Tom Bearden's technology, what exactly he was doing with the scalar wave, because he spoke that there were even different types of scalar waves as well. And I'll get into this in the lecture. Okay, so the next slide. Tom Bearden quotes. Okay, now if you ever heard Tom Bearden speak, and at the end of this video, I give a lot of links to Tom Bearden's videos here. And one of the things he mentioned is that all matter is made of trapped electromagnetic energy. And I'll get into that later on what Tom meant by that, okay? Because that was actually in some of the physics videos, YouTube videos that are out there. And you can watch these videos because I include the links to them. So all matter is made of trapped electromagnetic energy. Okay. And then the second thing that Tom mentioned is that we cannot see the dimension of time. Why? Because we consider time to be in the fourth dimension. Okay. But we know time exists, because a lot of physicists out there want to say, well, time doesn't exist at all and blah, blah, this and that. Well, that's not true. Okay. Because we know time exists because of spatial displacement. So Tom always spoke about that as well. Okay. So the next slide. I did some analysis here. And I looked at the electric force versus the gravitational force, okay? And you'll notice that, the electric force and the magnetic forces, they're considered to be vectors, directional vectors, okay? But the gravitational force is a bit of an oddball because it's spatial, okay? It's everywhere. And it's considered to be a scalar, okay? It's like time. I often say that gravity is time, time is gravity, okay? And so when you do the analysis here, you find out that the difference between the electric and the gravitational force is enormous, okay? Absolutely enormous. And so when you crunch out these numbers, it's 10 to the 42nd power times, the gravitational force is the electric force, 10 to the 42nd power. But what's very important about this is that it's not zero, okay? And that's what caught a lot of physicists, maybe 100, 150 years ago. And I'll get into that here, okay? The gravitational force is not, well, we know it's not zero, okay? So is there a link between electromagnetism and gravity and anti-gravity, okay? And personally, I would say absolutely, yes. And so we see that the electric and magnetic fields are transverse fields. They're considered to be transverse fields in this case. So we see the electron influenced by an electric field moves in a straight line, okay? The magnetic field moves the electron in a circular fashion, and both are considered transverse wave functions, okay? But now we see that the electron is, when it's under gravity, a gravitational influence here, gravity is considered to be longitudinal, okay, which is that it's acting in all directions. It's a scalar field or scalar function, okay? And when that field is gravitic, it's acting as a gravity field or a gravity well, time becomes slower. Time starts to slow down, okay? That's that delta T increases the time. But when we work with anti-gravity, which is what we do in this technology, gravity acts in the other direction, okay? The scalar field, it's a longitudinal field, but the electron becomes lighter, okay? And in this case here, the time starts to tick faster, all right? And we see that with some experiments. They did this a number of years ago, back in the 40s or 50s, where they flew in a plane, a clock, and they observed that this clock would tick faster, okay? Well, this phenomena also occurs in orbit, which is why they have to correct these GPS satellites to compensate for the difference in gravity, okay? And of course, I developed some field equations to make that calculation, and I call it natural relativity. And I even wrote a book on it that goes into some of this detail. So anyway, here we see that gravity and anti-gravity, they're scalar, what we call scalar fields. In other words, they're acting on matter or acting on mass in all directions. Okay. Same thing with time. Time is a scalar. Temperature is a scalar function. So let's go on to the next slide here. Einstein. Einstein tried to unify the field. He wanted to find a connection between electromagnetism and gravity. He couldn't do it. He spent the rest of his life trying to find out the connection between the two. He couldn't do it. And it's called his unified field theory. Was, of course, a complete failure. So even Einstein couldn't figure it out. Okay. But guess what? Modern science, we discovered this connection. And yes, we call it scalar waves. Okay. And we can produce this in the lab. This is something that you can do on your test bench. Scalar waves. Okay, so what does Tom mean by scalar waves? Well, they're best described as anti-gravitational waves that have the property of being both time reversed and longitudinal. Those are two important quantities here. Now, the time reversal part of this is generally done with optics. But guess what? We can do it at very low frequencies, okay, in our test apparatus here, okay? And many other researchers did this as well, okay, like Floyd Sweet, Nikola Tesla, Stanley Myers. They all produce this time reversed phenomena, and it's a longitudinal phenomena as well. So that's what the scalar waves are. Okay, so next slide. How to produce scalar waves. Well, this is the common technique that I want to say that everyone uses who's developing this technology. Okay, so what you do is that you set up your field, your magnetic field in this case, equal. They must be equal and opposite, and they must resonate. Okay, it must be a resonant condition here for the scalar wave term to appear. And you can actually see this on your oscilloscope. Okay, well, how can you see it on your oscilloscope? Where there's two different types of waves, okay, that your technology produces. So let's go to the next slide here. Two types of scalar waves are produced simultaneously. And this phenomena occurs with all the researchers that have worked in this field observe the same phenomena. And what it is time-reversed EM transverse waves. This is what you see on your oscilloscope. Okay. And then the other wave, scalar wave that's produced, is a time-reversed gravity wave. Okay. Or in this case, anti-gravitational wave. All right. I want to emphasize that. Time-reversed gravity wave. Okay. In other words, the device you're working on will become lighter in weight. Okay. So next slide. Now, what you see here, Tom spoke quite a bit about in his lectures. And this is what happens when you take these two charges and you oscillate them in opposing configuration here. And when you oscillate them like this, it produces something called a zero vector. And that's very important here because you need to understand what the zero vector is all about. Now, this character here by the name of Oliver Heaviside, a brilliant mathematician, came along and took the original Maxwell equations, the original Maxwell electromagnetic equations, and he simplified them. Okay, he simplified these equations such that The zero vector has nothing in it. It's empty, okay? But when you look at the original Maxwell equations here, the quaternion solution, James Maxwell included the scalar component in his calculations, okay? And that's very important here because when you drive this system with a sine wave, when you oscillate these fields, okay, and using a sine wave, you get something that comes out of this, which is the sine squared term, okay? And again, that's very important, the sine squared term. And so this is what you see on the oscilloscope, okay? You see the sine squared term on your oscilloscope. And so with the sine squared term, you get the zero vector. But Tom Bearden, he called the zero vector a vacuum engine, okay, because it has special content. And this special content is that it produces a scalar anti-gravitational longitudinal wave. In other words, the device is not only essentially canceling out the magnetomotive forces in your circuit, but it's also getting lighter. A researcher by the name of Floyd Sweet, and I think some people out there are still carrying some of his information. Floyd Sweet built one of these devices that oscillated and canceled out the magnetomotive forces, and the device became, well, what Tom said, 90% lighter in its weight. Okay, and that's very important because weight is the mass acceleration effect, and that's what we're seeing a decrease of. All right, so very important here. The original Maxwell equations, you want to work with that scalar entity, and that's what you actually see on your oscilloscope. Okay, so what happens here? You take your magical device, you put it on a professor's desk at some university. He's not going to have a clue how it works. Why? Because he's working with the Oliver Heaviside vector solutions, where the zero vector is empty. There's nothing there, okay? So he's not going to have a clue how this device works unless you go back to the original quaternion Maxwell solution here, where you have the scalar term, okay? And you operate this device in resonance. And I'll get into that a little later here as well. So your device is not only producing this scalar wave on your scope, but the device is also, the zero vector here is producing an anti-gravitational longitudinal wave that is, of course, anti-gravitic. It's going to get lighter. Okay. Next slide here. Oliver Heaviside, as I mentioned before, simplified Maxwell's electromagnetic equations. Back in the 1880s, he did this. And Tom likes to speak about this as well because it's the major flaw in modern mainstream science. Because Oliver took out the gravitational component that was there in the original Maxwell equations. The gravity is gone. So, and you can look at, okay, the slide that I had there, that I had up there previously, showing the difference between the electric and the gravitational force, 10 to the 42nd power. Well, Oliver came along and said, well, that's zero. And he said it's mystical and should be murdered from the theory. So he took out the scalar component, okay? And Tom Bearden's famous for quoting Oliver Heaviside, threw the baby out with the bathwater in his formulations, okay? And then what I say is that this is the main reason why we don't have Star Trek today, okay? Simple as that. Simple as that. We don't have Star Trek. Why is that? There's no gravitational component that's built in to the electromagnetics. All right. But since now we're correcting the theory, is that we put the scalar component back in. And how do we know it's there? Because we see it on our oscilloscope. We see the sine squared term. It's there. Okay. So the next slide. How to determine resonance? Because I mentioned that the system has to operate in a resonant configuration. Okay. So the output of your opposing coil configuration here, and I use what I call the split flux transformer. I have my own patent on this. And it's connected up to a capacitor and then a resistive load. So the whole system operates in resonance. And when it does so, you'll observe a current minimum on your input. Your input current has a minimum input at resonance. And this minimum input current can approach zero, such that when you do the calculations on the power for this device, it can go way over unity. Okay, 100% doesn't mean anything at this point. You know, everything is like governed. Well, our power supply runs at 98% efficiency, and that's the best we're ever going to do. Not true. Not true with these devices. Because when you set up these opposing magnetomotive forces in your circuit and you operate that in resonance, you find out that your efficiency can go way over 100%. And Floyd Sweet, I think, went over something like 10 million% in his device, 10 million%. And that's phenomenal, okay? And that's all because of his minimum input current approaching zero. Okay, so that's a very important part of this. Next slide. All right, PCM resonators. And this is what Tom ended up calling this, because you have your opposing output coils driving a capacitor. Okay, so part of your load here is a capacitor. And he called it a pumped phase conjugate mirror. Okay, is what happens here. I ended up filing a patent back in 2020 on this particular configuration here. And then Tom Bearden lectured on this subject back in the 1990s. Okay. So next slide. PCM resonators. It outputs a time-reversed transverse EM wave. The output becomes more efficient, and efficiencies can exceed 100%. You're no longer limited by the 100% barrier. Okay, that's like going beyond the speed of sound, right? You have to break the rules here to do it. So here we exceed 100% efficiency because the signal is time reversed. Okay, we're working with a phase conjugate mirror, setting up in a resonant situation here, configuration. The output device outputs an anti-gravitational wave as well. Okay, the scalar waves, okay, decreases its own mass acceleration effect. The weight can become negative or less than zero. Okay, next slide. The split flux transformer. Okay, this is what I have a patent on. You can look up this patent. Okay, I filed it back in 2015. We finally got it granted under the Trump administration here. I believe it was back in 2020 or so. I'm the inventor of this transformer, and it consists of a primary coil arrangement and then two secondary coils that are set up in opposition to one another. Okay, And to get it to resonate, that you hook it up to a capacitor and a resistive load. Okay. So next slide. PCM resonators here. Now, Tom spoke about this, but I'm going into far more detail what Tom was speaking about. Okay. Because Tom spoke about a four-way mixing process that occurs in this device. So what you have top and bottom, wave 1 and wave 2, that's your input sine waves. Okay. So if we go back, let's go back a couple of slides here. So for wave 1 and wave 2, right here, is that we see the opposing forces on the secondary output. Okay. And that's driven by these two coils, L2 and L3. And that sets up your PCM. Okay. So if we go back to this slide here, now this detail here also shows wave 3, which is really the result of wave 1 and wave 2. And that produces your sine squared term. Okay. And wave 4 is your output waveform. And wave 4 output, you'll notice it's magnified. Okay. It's a magnified output. And it's sine squared. And that's what a sine squared wave looks like. That's what a scalar wave on your scope would look like. Okay. Next slide here. So when we look at the output, the input and output of a PCM, we see the small W3 waveform on the input and a large W4 waveform on the output. And so there's some gain here. It produces a gain function. You know, it's a time reversed EM wave that you see. And what's curious about this, well, why does it increase the efficiency of your output? Because it's time reversed. Okay, obviously, right? It's a time reversed wave, and it increases the efficiency of your output. And that efficiency can become quite large. Okay. I would say that Floyd Sweet, for example, had something like a 10 million% increase in his wave function. Okay. And that's because the input is so low. Okay. The history of opposing magnetomotive forces. Well, we have to include Nikola Tesla here with this magnifying generator. So what did Nikola do? Well, you'll see his M coils here set up an opposing configuration will create this phenomena. He has two output capacitors, and that's driving a transformer output. Okay. So it's a scalar wave generator is what he's doing here. So and he called it a magnifying generator, which is what we're seeing here. It decreases the input power and then increases the output power. Okay. So he calls it his magnifying generator. You can look up this patent. It's out there. He did this back in 1896. So we have to include Nikola as probably a pioneer with the scalar wave. Okay. You know, and his tower that he built out there in Colorado. And this is the electrical diagram of what Nikola Tesla was doing. Okay. You'll see the generator up there at the top driving two coils labeled M. And that, of course, is driving his capacitor network here. And in turn here, driving his output transformer. Okay. So this is what I think Nikola Tesla was doing with his scalar wave system. So next slide. Now, here's a very curious inventor by the name of Stanley Meyer. And we know from At Tesla Tech here, this Max Miller gave a lecture, I don't know, about maybe 5 or 6 years ago, replicating all of Stanley Meyer's work. And he observed the same phenomena that Stanley observed in his technology. And of course, you'll see the opposing coil configuration here, okay, which is labeled 71 and 61, the output. And we'll get to that in a minute on some of the details here. But the objective for Stanley Myers and his water car is to burn water, not gasoline. And guess what? That would really clean up the environment, wouldn't it? Burning water instead of gasoline. No hydrocarbons, just water. Okay? And there's his patent. You can look this up for more details here. So next slide. Okay, this is what Stanley Myers was doing with this transformer. Very important here because he's setting up his opposing magnetomotive forces on his output, which drives what's called a water capacitor. Okay, it drives a water capacitor on his output. And what is a water capacitor? Well, it's just a couple of plates and using water as a dielectric material. Okay? And so what he's doing is creating what's called Brown's gas. And I want to emphasize that, Brown's gas, because you'll find that with Yule Brown, and he's credited with naming Brown's gas. And what we're doing here, we're not separating hydrogen from oxygen. We're not doing that here, okay? Because you put that in separate tanks, and then you burn that as fuel, as rocket fuel, okay? We're not doing that. What we're doing instead is creating what's called a hydroxy gas, and includes both hydrogen and oxygen in these bubbles, okay? And so Stanley took these bubbles and fed it into his carburation system, and that's what he used as fuel. You can actually burn this hydrogen-oxygen solution, this hydroxy gas, as fuel. And we'll get into that here. Next slide. So what is water fuel? What is this stuff that Stanley was producing, as well as Yule Brown, this HHO gas, Brown's gas? It's hydroxy gas, oxyhydrogen gas. It goes by several names, and it's highly flammable, okay? The other curious thing about it is that the gas burns cold. It doesn't burn super hot. And it burns at a temperature of 266 degrees Fahrenheit or 130 degrees centigrade. But it can vaporize tungsten, all right, which can melt at over 10,000 degrees Fahrenheit, okay? So the flame is actually an electric flame, okay? Very curious thing. And so the objective here is, of course, burn water, not gasoline. And of course, there's a book out on it. Maury King wrote a book, The Key to New Energy, and I know it's available on Steve Ellswick's website, okay? And it goes into a lot of detail on his Brown's gas. So I would call it fuel of the future. You can replace gasoline with it, okay? So rather than burning gasoline, you burn this water, this hydroxy gas. And that's a project that I want to work on as well. So next slide. And there's this apparatus here. You can buy this off the internet. It's an HHO Brown's gas water torch, okay? You can buy this. I believe it's made in China. Well, of course, everything is. That's the way everything is set up here. It's all made in China. So you can buy this water torch and burn water, okay, because it makes the gas. Now, in this case here, you have to use a catalyst. Okay. You see that power supply in the back? That's generating a DC supply, which is turning this water. It's a water solution, okay, that they use. I believe they mix it in with potash. Gets mixed as a solution here. And so you have to pass a high current. It's like 30 amps or so. See, with our tech, what we want to do is minimize that power as much as possible. Okay. So we want to use scalar power. This is what Stanley did. Okay. And we want to use scalar power input to make this gas, and you don't need to use a catalyst. You can use straight distilled water as your fuel source. Okay. So next slide. Now here's something very interesting I ran across. I would say maybe a year or two ago. This video. You see the link at the top. You can watch this video, and it's called Relativistic Quantum Field Theory. And when I saw this, I was just shocked. I was just shocked because you see particles with mass on the left side of the equation. And what do you see? You see the sine squared term, that frequency minimum. You make that your sine wave input, and you square it. Well, what is that? Lo and behold, that's our scalar wave. So it's the scalar wave that is producing gravity. Okay, it's particles with mass. So there it is, what Tom Bearden said. Matter is made of trapped electromagnetic energy. There it is, right there in the field equations. On the right, you see what is that equation for a photon? Something that's massless, or you set it equal to zero. There's a photon that has no mass, very well known in physics. But on the left, you take your particles, right? Electrons, protons, neutrons, they all have mass, right? Well, they're made of what? Scalar waves. There it is. There's your sine squared term. So let's move on. Next slide. Okay, the scalar wave test bench. This is what any scalar wave scientist must have, a scalar wave test bench. Okay, so there's your power supply on the right. I recommend these GW Instec power supplies. They're very good. You can vary the AC voltage on them through a whole range of voltages, and they're available in various outputs. You can get this from Newark Electronics, and it's the perfect power supply for driving your scalar wave device. So in this case, I'm using my split flux transformer, capacitor arrangement, driving a load resistor. And there, up there on the screen, you see some very interesting software. And so what I do is I hook up all the meters to this test bench. So I'm looking at all the voltages coming in, coming out, looking at all the currents coming in, coming out, and looking at the phase relationships, okay, between all these wave functions that's being generated here. And I highly recommend this scope. It's an old scope, okay. I think Newark is still carrying them. They're available, I think, through Newark. It's the Tektronix 2024B. And what's so important about this particular scope is that it's isolated channel. You need to use a scope that has isolated channels, okay? Because you don't want a common ground going on here. It'll just short out everything. So use isolated a scope, and I take all my measurements here, and I wrote software that reads the scope, okay, that reads all these voltages and currents. So my software interrogates the scope, and gets the readings and displays everything there. Okay, so you're looking at all your phase relationships and power, this and that coming in and out. And the one thing that I noticed, next slide here, and I call it transformer efficiency calculator. That's what the software is. And it's available on my website. Okay, you can download it on my website. And it works with this scope. And these are the waveforms. I have an old version of MathCAD that does the job perfectly here. Look at the input waveform here. That's your sine wave input. The output is, of course, a scalar waveform, which appears at resonance. Okay, that's your sine squared term. Now, of course, you can't see this directly. And the reason why is that the scope will add these two waveforms together and give you the third waveform on the bottom. This is what you see on your scope trace, is the waveform on the bottom. It's a summation of your input and scalar waveform. Okay? So if you have some technology there that can subtract out the input waveform, the scalar waveform is what you see. Okay? That's your sine squared term. All right, so this is what you see. If you have a scope, and of course I have my 2024B Tektronix scope, this is what you see on the output. You see the trace on the bottom there, the yellow trace, that's your input waveform. And you see this sine plus the sine squared term, okay? Now, when you do your AC circuit analysis, this is what you want to do, okay? You have your input on the left, generating your sine wave, and then on the output, you have your resistive load, okay? And you're looking at these various phase relationships here. And so the device under test, what generally called the DUT, device under test, that's your transformer capacitor arrangement, okay? And so with these various resistive loads, when you go and calculate power, which is what my software does, calculates power, looks at the phase relationships here, and computes the COP, which is the ratio of input and output power, okay? So efficiency equals the COP times 100%. That's generally less than 100% with conventional power supplies, okay? So next slide here. And lo and behold, when I test my transformer, I get an efficiency of almost 90%, which is very interesting because this typical efficiency on transformers are generally between 70 and 80% efficient. So most of your electric energies is, of course, converted into heat. And this is why you're below 100%, okay? So in this case here, the efficiency has gone up. And this is how you know you're working with a time reversed wave, because that's what it's going to do, increase the efficiency of your test apparatus here, okay? So when you build these opposing magnetomotive force transformers, this is what's going to happen. Your efficiency is going to go up because you're generating this time reverse scalar wave, okay? The device is going to become lighter. Now, of course, you can put this on a very delicate beam balance, okay, to see if your device is losing weight. And as long as this scalar wave term here is time reversed, it's of course going to output a time reversed gravity wave or an anti-gravitational wave as well. Okay, so next slide. Okay, transformer efficiency calculator. This is what it's doing. These are all the various calculations that's being done here. And of course, you're looking at voltages and currents, looking at phasing between the two. There's a lot of cosine operations going on here, advanced mathematics. So you're also looking at power calculations, computing the efficiency of the system. And that's actually hard to do here because you have to work with that sine squared term. Okay. That kind of, I would say, throws a little monkey into the wrench here. Okay. And into this calculation. But nevertheless, it manages. And you can see the efficiency going up. And that's the important thing. Okay, is that the efficiency of your device goes up, and that's how you know you're producing time reverse phenomena and producing an anti-gravitational wave. Okay. Next slide. These are various slides that I captured in my software, and I just download them to the clipboard and then print them out on a printer. Okay. So it's one of the key features of my software is that it captures the input and output. All right. So, well, what's Tom doing here? Well, I think Tom held back on a lot of his material. And what did he held back from? Well, he wanted a big DARPA contract. Okay. The man wanted a big DARPA contract, and it never happened. But he wanted to give the military all his secrets, all his scalar wave interferometry defense applications. Okay. And what's so interesting about the scalar wave interferometry, and Tom spoke about this in his lectures, in light detail, but nevertheless he spoke about it as a defense application where he uses two ground-based scalar wave emitters. Okay. And the region where these beams cross, okay, with the beams, where they cross generates a region of space that is highly electromagnetic. Okay, and it can destroy electronics in that target zone where the beams cross. And so here's the scalar wave interferometry. What is Tom speaking about here? Well, you can see the scalar waves, okay, and how they construct and deconstruct where they cross. You can either create a virtual ground or you can create a huge electromagnetic potential, and that'll fry your electronics. Okay, guaranteed. So next slide. And then here's the scalar wave interferometry. Again, you have two scalar wave emitters. One generates the virtual ground, the other one generates the high potential. The region, of course, you point it at your enemy here that's coming into range and fry their electronics. Yeah, that's what it does. Next slide. All right. Well, I came across this researcher here by the name of Boyd Bushman, and I come to understand he does have some patents out there. And so Boyd described this fascinating experiment that anyone can do, okay, with magnets. And he described this in a video that David Sereda made, From Here to Andromeda, I believe it's called. And he has a segment here with Boyd Bushman describing this experiment and a drop test he did at Lockheed. He passed away several years ago, but he left behind this this description of an experiment he did that what it did is change the mass acceleration effect. Okay. And what did he do? Well, he sets up opposing magnetic fields Well, isn't that what we're doing in our scalar wave system? Of course it is. We're setting up an opposing magnetic field in our technology here. Well, Boyd did the same thing, except he used neodymium magnets, and he forced these magnets together. And he describes it as bolting them together and kind of wrapping it up, making it look like a rock with electrical tape. And he has his other test rock, and he drops it down an elevator shaft at Lockheed, where he worked. And so what he observed is that the opposing magnetic fields generated this anti-gravity field. Well, isn't that what we're talking about here with the scalar field? This anti-gravity mechanism that's involved there? He observed a decrease in the mass acceleration effect. In other words, the rock fell slower than your test rock. Well, we know that that doesn't happen with any kind of material. I mean, didn't they show that on the moon? Okay, one of the astronauts had a feather and a hammer, and then he dropped the two on the moon's surface, and they both fell at the same rate. Okay, but in this case, we don't see that. We don't see that effect. So magnets, while producing a magnetic field, bends space-time, and in this case, generates an anti-gravitational field using magnets in the opposing configuration. So what did Boyd do? What exactly did he do here? Let's go to the next slide. Well, this is the experiment that I replicated, okay? Because I replicated his drop test, okay? I did this in Sedona at the Sedona Life Center. My helper up there at the top, and on my cue, he would drop the magnet and the rocks, okay, the magnets in the opposing configuration. And I videotaped it, and I did make a video of this. And you can actually see about a foot, maybe a foot and a half difference between the rock, okay, and the opposing magnetic field, okay. And then thinking about this, I said, well, okay, well, let's use some magnets in the attractive configuration. And what does that do? Well, guess what? It would increase the mass acceleration effect, okay? In other words, the attractive configuration would fall faster than the rock, okay? And we'll get into this a little later in this lecture here on what that means, okay? So these magnets in attractive configuration would fall faster, but the magnets in the opposing configuration would fall slower, okay? And so I successfully replicated Boyd-Bushman. Anyone can do this, okay? Anyone can do this test. And I show exactly how to do it here. There's my test jig, okay? This is the drop test. It shows the test jig here on the right, magnets on the left here, and there's two magnets here, and they're set up in their opposing configuration, okay? And I just epoxy them together using JP Weld. Works great, okay? So there's the test jig, and I'm making my magnet assembly in opposing configuration. There's the test jig, and the magnet assembly there is at the bottom, shows it in the north-north configuration here, epoxied together. And there's the assembly, the two magnets epoxied together. And there's ordinary rock. Well, they have lots of these in Arizona. You can go to any yard and pick up a rock. That's your test subject there. So there's your test subject in the center there, ordinary rock wrapped up in electrical tape. I put a white band on it so it shows up in video. On the right shows your opposing magnets. On the left, magnets in the attractive configuration. Okay. And there's the test that I ran. I did videotape this. I observed that the magnets in the opposing configuration fell slower. In the attractive configuration, they fell faster than the rock, control rock. So what does all this mean? What is the point of all this? Well, this fellow came along, about 20 years ago, and published a paper. Alcubierre wrote a paper on warp drive technology. Well, guess what? We can build a warp drive using magnets, okay? And the opposing configuration and the attractive configuration, because they bend space-time as well. They emit a scalar field. The opposing configuration's anti-gravitic, okay? The field on the left is gravitic. They both emit longitudinal fields, okay? So you can build a warp drive with this. And so I came up with this diagram here. The ABA, that's the Alec Bushman Alcubierre warp drive engine propulsion technology. Okay. Shows how it warps space. On the right there, top right, you see the engine, okay, in the direction of motion. On the bottom right, you see, hey, doesn't that look like Star Trek? Well, lo and behold, when you, I was fortunate enough to meet someone who knew someone, all right, in the LA area back in the 1960s. He was a channel for extraterrestrials, and they spoke about this kind of technology. Oh, yeah. This is how the writers came up with Star Trek back in the 1960s by going to a week. It wasn't a weekly. I believe it was a monthly meeting. It was called Mind, M-I-N-D, by Jacques Dubier. He was a channel for extraterrestrials, and he spoke to these writers that attended the meeting how to do Star Trek. Fascinating, huh? Well, this is how you do it. You see the double nacelles on the right, bottom right of the craft, okay? And they spin in counter configuration here. They counter rotate. That's because there's the P factor effect that you have with airplanes, okay? Why they counter rotate as well. The propeller effect or the P factor effect here. So that's what you have. These spinning magnetic fields that bend space-time, okay, generating a warp field, okay? And this is how you do it, using magnets or magnet technology. And you spin these, when you spin these magnets, it amplifies the field effect. They call that the Barnett effect, okay? So next slide. I'm not anti-gravity, but our technology is. I thought this was a cute little thing that I have here. There's my card. This is how you reach me. And lecture references. I suggest that everyone check up these references. There was a movie on time reversal called Tenet. Came out, I think, a few years ago, played in theaters, and it involves time reverse technology, okay? And then here's Bearden's psychotronics lecture. I suggest you see that. Evolving ideas involving Tom Bearden's research. Great interviews here. Another psychotronics lecture. Here's one on scalar physics. I recommend this video here. It's the future of electromagnetics. is scalar physics. Okay. And of course, my previous interview here with Steve Ellswick. Here's the Boyd-Bushman drop test experiment. Okay. So you can go to YouTube and watch that. And that concludes my presentation. So this is how to reach me here. And that's the show, Steve.
Well, if everyone wants to give a hand, just hit that thumbs up there. It does register. And
All right. So I go into a lot of detail here. Next year, at your conference, I do want to go into more detail here. Okay.
well, we'll be looking forward to seeing you at the conference. I want to take that as a moment to remind people to get their call for papers in. I need the abstracts by November 30th so I can try to get this program done earlier, and really try to boost our attendance, These conferences are very important. I don't think people realize how important they are.
Especially now,
but our conferences helps develop a sense of community. The problem that we have in this field is that there's no sense of community. They have these Zoom conferences and everything, but you really don't have a sense of community unless you're actually there physically and can meet people. I was watching some music videos today, and I used to be in the military, and boy, it just brought back a lot of memories. Like when I was in the military, we were all there and we had a sense of community. When I go to these conferences, I have a sense of community with those who I see at these conferences over and over and over again. It's like a family reunion. You get to meet people there and break bread with them, and you just don't get that through Zoom, and you don't get to talk to people off the record. In private. Everything has to be on camera these days. There's no sense of privacy, and it makes it really hard to share. So I want to encourage everyone to come to our conference next year. It's going to be August 7th to 11th. In Albuquerque, most likely at the Crown Plaza. One of the reasons I use the Crown Plaza is because we get such great hotel rates there. You're in the 80s, $80 a night, roughly. And that includes breakfast. And you don't get that anywhere else. You go, I'm looking at possibly going to this conference in Flagstaff maybe this week, a Dow's conference. The conference site wants $160 a night, And there's no way I could do that, And a lot of people just can't, it's just too much, So we keep everyone's costs, and we also have something to eat every night, where we can sit down and talk to people, and learn stuff that you're not going to learn anywhere else. You're not going to see it on the video because it's at dinner and everything. So, and you get to meet people and become friends. So, anyway, here's a question here. Let me get off of here. Okay, you discussed the weaponization of scalar waves. I have to ask you about the opposite. Can you discuss the marvelous health benefits?
Oh, okay. Yeah, we developed a pad. Okay, when you set up these opposing fields, these magnets, we created a pad that has an array of 4 of these opposing magnets. Okay, and you put the pad on your back here, and it takes away the pain of driving long distances. It's great. It's fantastic. And so we started making up some of these pads for people. Okay. So the health benefits are rather interesting. with the scalar wave. It accelerates plant growth. That's one of the things that we did. We did testing with one of these magnets. We placed it at a base of a plant, and the plant just grew. I mean, healthy. It was a healthy plant. So I would say there's incredible health benefits with the scalar wave. And another researcher that comes to your conference as well is with the, I forget his name, but he presents at your conference. But he has those gas generators. Okay,
George
and you can
Weissman?
breathe in.
George
Yeah, Weissman. George Weissman. Okay, has those gas. You can breathe in that gas. Okay. And there's some health benefits from that as well.
And he's been a speaker a lot too. And if you go to our program from last year, next year, there'll be like a link to his website for the hydrogen in that. Okay, can you talk about the reverse flyback voltage regarding any of Bearden's work or others?
As far as I know, this doesn't use a flyback configuration. Okay, a flyback transformer. You just set up your ordinary transformers, but they have to be, the output coils have to be to generate an opposing magnetomotive force, okay, in your magnetic material. And when they do that and then they resonate, okay, with an output capacitor, is where you see that scalar wave function manifest. Okay. And that's where your input current starts to really drop. And so you see these huge efficiencies in your device, okay, because the input current is dropping. And this is what Floyd Sweet saw on his device. You know, he had something like 10 million%. So you can go well over 100%. The 100% barrier is no longer a barrier, okay, with this kind of technology. So you want to set up opposing magnetomotive forces on your output of your device, okay, to create the scalar function. And it's time reversed as well, okay, and produces the anti-gravitational effect. So I hope that kind of answers that question there, because I know some researchers have used flyback transformer configurations in the past, but they're using it. One device used a flyback configuration that drove a fluorescent tube, okay, and the fluorescence has an interesting property. Uses a mercury vapor inside of these fluorescent tubes, and that mercury vapor has some interesting properties associated with it. That is a negative resistance. There's a negative resistance associated with that. So there's some technology that I saw a number of years ago that used a flyback in that kind of configuration. But here we're just using regular transformers, but the transformers are set up in this opposing configuration.
Okay, and then here's a comment about Bearden. Briefly discuss the far ultimate health benefits in one of his books.
Mm-hmm.
I believe that book was back in 1986, and it was AIDS biological warfare.
Uh-huh.
And
right.
then also here's another question for you. Are these devices mostly pulse DC?
They can be. Okay, it has to be pulse something or other or an AC wave, because that's how transformers work. Okay, they have to oscillate. They have to have a changing field, okay, to produce an output. So it could be pulse DC, like in Stanley Meyer's technology. I think we're using square waves. Or it could be a sine wave. But yes, you can use pulse DC.
Okay, here's another one. Beard mentioned to send energy to an area, you must have a higher potential to the target area. To draw energy out of a target, you must have a potential, or how do you determine the potential?
Oh, it's due to the phasing of the scalar waves. Okay, you change the phasing. Okay, so if the phase is in opposing configuration here, you get a cancellation of the field, and you can generate what's called a virtual ground. Okay, but if they're shifted 180 degrees, then the waves will add. Okay, and that's what I show in the video here in the conference, is how you adjust the phasing to add or subtract. Okay.
Okay, well, with that, I'm going to kind of bring everything to a close here. And I'll be looking forward to seeing you there in Albuquerque.
Mm-hmm.
And I hope a lot of our people who's watching this will come, and don't keep us to yourself. Let other people know about us. You know, we don't want to be the best kept secret in science.
Right.
You all have a great night, and I'll see you next week.
Okay. Thanks, Steve.
Okay, thank you.